Now we're going to look at solving systems of linear equations algebraically. We have two methods. The first method we're going to look at is the substitution method. There's certain things you need to look for in order to choose the substitution method. First, look for a variable appearing in an equation with a coefficient of 1 or negative 1 and isolate that variable in its equation. We're going to substitute the expression obtained for the isolated variable into the other equation and solve for the value of the remaining variable. Substitute that value into either of the original equations and solve for the other variable, and you write your solution as an ordered pair. So here's an example. I've got this system, but guys, notice step 1. Look for one of the variables that has a coefficient of 1 or negative 1. So as you compare, the only one that satisfies that is this y right here. So it says, notice in the first equation that the variable y has a coefficient of 1. Therefore, isolate the y in that equation. So I would add 2x to both sides. Now normally when I isolate one of the variables, I put a circle around it, and I'll tell you why here in just a bit. So now we're going to substitute this into the other. It must be the other equation. So this is the one we solve for y. So in this one, this is the one I'm going to put y in for. So I've got 2x plus 3 with parentheses because they're of equal value. I can substitute that in, equal 5. Now if you'll notice, I've got an equation, one variable, and I can solve for it. So distribute the 3, collect like terms, isolate the variable and the constant. So in this particular situation, x needs to be 1. Okay? Now why I circled this a little bit earlier is because that would be the easiest place for me to go back and put 1 back in. So if I do that, I end up with y equals 1. So a good idea on this is to put the point 1, 1 back into both of them and see if it gives you a true statement. So if I put 1 in for x and y, it indeed does give me negative 1 equals negative 1. And if I put 1 in for x and y in this one, it does give me 5 equals 5. So my solution for the system is the ordered pair 1, 1. And graphically, this means that these two lines intersect at that particular coordinate point. Now we've got substitution for these. So as you look through here, the one that I should use should be this very first y. So I would probably add 7 and add y. Let's see if that's what I did. Yep, because that was the quickest way. Now circle this. Let me borrow this thing just a second, because I'm going to be coming back right there. So then I'm going to put this into the other one. So with parentheses, I'm going to put it in place of y. So let's see if I did that. Distribute through, collect like terms. So x would be negative 2. Substitute it back in here. So if we put negative 2 here, it looks like y should be 3. And then write your answer as a ordered pair. Do double check. You double check and it should work. But that is a quick way to check yourself to make sure if you've got your answer right. Alright, now this one. I would probably solve for this y. So I would add 3x to both sides. I'm going to go borrow that again. It's just easier for me to find it if I do that. So let's substitute this into the other one. Let's see what we get. Distribute. Collect like terms. We have 0 equals 0. Now we didn't graph this. You need to know what this means. Anytime you end up with a true statement like this, 0 equals 0, that means you have the very same equation. They would graph to be the very same line. So this means I have infinite number of solutions. Okay? And I think that's it for this one. Now, just say for instance, or for an instant, that when I did this I came up with a false statement like 0 equals 7. That would be a false statement, and that would indicate I've got parallel lines, which means my solution would be no solution. Okay, so you need to try some of these problems. Thank you.